Hello, today we are looking at enlargement and scale factors. Okay, now enlargement basically means making things bigger. But obviously, being mathematics, we know that we don't just work in one direction. We can work in several directions at once. So when we talk about enlargement, we talk about things getting bigger and things getting smaller, and it is the same word. Now, how much they get bigger by or how much they reduce by is the scale factor. So be aware, when we talk about enlargement in mathematics, it's not always about getting bigger. It can be about getting smaller. And we'll have a look at some examples of both in this. Okay. Now, the scale factor is one of the key things that we need. And the scale factor tells us by how much. Okay, and this is essentially what we are multiplying each dimension by. Now, all of the shapes we're looking at today are 2D shapes. So we're talking about enlarging each dimension by a scale factor of that. So if we measure a side and we know the scale factor, we can work out what the new side is. Now, because I'm filming this, I'm using pen so that it is nice and clear on the video. But obviously, when you are doing it, you need to be doing it with pencil. Likewise, it's another one of those things that really should be done on squared paper. Okay, and that will make life a lot easier for you. Right, so let's have a look at this first question. Let's call this question 1. Okay, we have a shape here. It's a simple L shape. And I am telling you we're going to enlarge it by a scale factor of 3. So what that means is we're going to take each of these dimensions and we're going to multiply it by 3, and that's what the scale factor is. Scale factor SF, multiply it by 3. So if we take this top side here, it goes along 2 squares. So if that is 2 squares, when we multiply that by 3, our new shape will be 6 squares. So immediately I can get that drawn. She says flinging the ruler around. 6. 1, 2, 3, 4, 5, 6. There we go. Again, that is 2, so we'll be coming down 6 again. Another 2. Another 6. 6, another 2, another 6. 1, 2, 3, 4. Can't count. 1, 2, 3, 4, 5, 6. Right, 1, 2, 3, 4, 5, 6. Just right. Okay. Now this bottom one here is 4. 4 times 3 is 12. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then we finish the shape off there. Okay, so just to recap, 2 times 3 is 6, 4 times 3 is 12, and when we count up these squares, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Hang on, I've done something wrong. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Drat! Just goes to show that I make mistakes too. So, because I've got all of these correct, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I'm going to take one of them. Obviously, if I had a pencil, I'd be able to rub it out. Hence, really should do it in pencil, but there we go. Just goes to show that I'm human still. Okay, so just to recap, multiply 3 also shows the importance of double checking. Okay, let's do this one next. Let's call this shape. Oh, that's the other thing I need to tell you. The notation. I'm calling this shape A, and A dash, or the image of A. Okay, shape A dash, the image of A. Now that's the first image of A. If I was then to do something else onto it, I'd call it A dash dash. Okay, and you'd label them up like that. Shape, question 2, shape B. This time I'm going to do it with a scale factor of 2. Okay, and I'm going to move it over here so there's a little bit more room. So same principle again. 1, 2, 3, 4, 5, 6. So that's a 6. 6 times 2 is 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm going to double check it this time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Hoorah! 2 times 2 is 4. So that's going to come down there. 4 times 2 is 8. 3, 4, 5, 6, 7, 8. And that comes down there. 2 and 4. I'm going to totally run out of space on here, aren't I? Not very good planning, Mrs. Patmore. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There we go. Just double check. 2, 4. 1, 2, 3, 4, 5, 6. 1, 2, 3. Oh, hang on, no. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Hoorah. So that is obviously the image of B. Okay. This one here, I'm going to call shape C. But this time I'm going to do as a scale factor of a half. Still an enlargement, but this time instead of the shape getting bigger, because the scale factor is a half, the shape is going to get smaller. So 1, 2, 3, 4, 5, 6. Half of 6 is 3. 1, 2, 3, 4, 5, 6, 7, 8. Half of 8 is 4. Okay. Image of C. Now at the moment it doesn't matter where physically I draw these on the page, but you need to be able to draw them, enlarge them by the scale factor, how much I've enlarged them by. Okay, make sure that's all in the kit frame it is. Okay, I'm going to give you 2 questions to do. Let's call this question number 4. 1, 2, 3, 4, 5. There's that. And call this shape letter D. Can you draw the image of D with a scale factor of 2? And question number 5, I'm going to come down here deliberately. One, 2, 3, 4, 5, 6. Okay, this is going to be like an upside down L. Make sure that you're counting your squares correctly, and I want this one of a scale factor of a half. As always, pause the video. It's just gone off the page there, sorry. As always, pause the video, draw it out, check back in. Okay, scale factor of 2. 1, 2, 3, 4, 5, 6. So that means that's going to 12. I'm going to draw it underneath so it saves me a bit of counting. I know that's 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And that is obviously the image of D. Scale factor of a half, so it means we're halving each of the sides, and I've just realised I've made that far trickier than it should have been. drat. Oh well, still have a go. 1, 2, 3, 4, 5, 6. So that's fairly easy. That's a 3 and a 3. But this is 3. Half of 3 is 1.5. That's a 3, 1.5. And of course, as I say, sorry about that, made it slightly trickier than I need to have. You, of course, can get half squares as well, obviously, but it's worth saying. So, just to recap, we're given a shape, we're given a scale factor. We multiply each of the dimensions by that scale factor. So the shape has enlarged by that scale factor. Likewise, we can also work the other way round. We can be given two shapes and find the scale factor. Okay, what letter was I up to? E, F. So this is F, image, G, G's image, H image, I, don't use I, J, and J's image. Now, it all depends on which way round you are doing, okay? If we're going from F to F's image, it means we're working this way. Now, if we're working from F's image to F, the scale factors will change, and we'll have a look at both pairs every time. So we want to know the scale factor. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. What do we multiply 3 by to get to 9? Well, 3 times 3 is 9, so we are saying the scale factor is 3. Let's double check that. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Excellent. And 4 times 3 is 12. Now let's have a look at it going the other way round. This time we're going from the image of F, this larger shape here in this case, to F. Image of F to F. So if that is 9, what do you multiply 9 by to get to 3? It is a third. What do you multiply 12 by to get to 4? Again, you're multiplying by a third. Scale factor of a third. Okay, let's do another example. G to image of G, image of G to G. So, same principle again. Well, there's only 1 on that side and there's 2 on that side. So 1 times 2 is 2. So we're saying scale factor is 2. Let's double check that. Down here, 1, 2, 3. 1, 2, 3, 4, 5, 6. Excellent. That's 6. 3 times 2 is 6, so we know we're right. Again, reverse principle, going from this shape to that shape. 2 times what is 1? 2 times a half is 1. Double check. 6 to 3. 6 times a half is indeed 3. So the scale factor going from the image of G to G is half, and from G to the image of G is 2. Now you can actually see there is a connection here. Okay, and when working in reverse, the scale factor is what we call the reciprocal. Now we will look at this in far more detail in Form 8, but it's worth mentioning 2 connections. Over to you. You don't have to draw the shapes out if you don't want to, but you can obviously as part of your notes. We're going from H to the image of H. I want to know the scale factor, and from the image of H to H, again I want to know the reverse scale factor. Same principle here, J to the image of J, and from the image of J to J. Okay, same principle, just be aware on this one. Think about you going from larger to smaller, smaller to larger, so just be careful. As always, pause the video, work out your answers and then check back in. Okay, let's have a look. So this height here is 2. 1, 2, 3, 4, 5, 6, 7, 8. That height here, there is 8. 2 times what is 8? 2 times 4. Squeezing that in there. I'm just going to put a line there so it's a little bit clearer. Double check this. 1, 1, 2, 3, 4. Excellent. So the scale factor of 4 stands. Right. Reverse image. 4 times what is 1? 4 times a quarter. 8 times what is 2? 8 times a quarter. Reverse image. Reverse working. Okay, final one. So we're going from here to here. So this one is 3. This side here is 1. 3 times what is 1? 3 times a third is 1. Double check that. 1, 2, 3, 4, 5, 6. 2. 6 times a third is indeed 2. Excellent. So going the other way from the image of J to J. And the scale factor. 1 times what is 3? 1 times 3 is 3. Double check. 2 times what is 6? 2 times 3 is 6. Excellent. All correct. So to recap, when you're finding scale factors, find a side, count up and work out what you multiply by. And if the shape's getting smaller, it will be a fraction. When the shape is getting bigger, it will be a number over 1.